Hello class. This video we continue working on review for exam 3. Question number 21. Factor, be sure to look for common factors first. So this polynomial is a trinomial. And then when I look at the first term and the last term, I notice the first term is a perfect square. Perfect square, 49 is 7 squared, right? X squared. And the last term is 5 squared. If the first base is 7x, the second base is 5 because 25 is 5 squared. And I multiply the two bases together. I have 35x, double 35x, I have 70x. So the middle term happened to be twice of the multiplication of the two bases, right? So basically, I'm saying this trinomial is a perfect square trinomial. The two bases are 7x and 5. So we can factor this trinomial as 7x plus 5 to the power of 2. I need to make this smaller. So to factor a perfect square trinomial, the result is going to be a square of a parentheses inside the parentheses. In this case, we have the sum of the two bases, 7x plus 5. 7x plus 5. All right? You can double check by FOIL or box method. 7x is the first base. 5 is the second base. Next, question 22. Factor. This trinomial is degree 3. Yeah, that should draw your attention. When the trinomial is degree 3, it's very likely that we are able to factor an x out. And it is the case. Numerical part-wise, 14, 17, 5, GCF is 1. So the GCF of this trinomial is x. Let's factor x out. Factor x out, we have 14x squared minus 17x plus 5. All right. And how do we factor the quadratic trinomial inside the parentheses? Let's do shortcut. Let's do slide by slide method. Slide 14, to multiply with 5, we have x squared minus 17x plus 14 times 5 is 70. 70 is a very convenient number, right? That means we have 97, 10. 97, 10 multiply to 70, right? 97, 10 multiply to 70, add up to 17. So those are the two numbers. And then we're going to divide the two numbers we got earlier by the leading coefficient 14. Do not forget to simplify. 7 over 14, half. 10 over 14, 5 over 7. And then we're going to slide it back here, here. Then the trinomial inside the parentheses can be factored as 2x minus 1, 2x minus 1, times 7x minus 5, 7x minus 5. Enter x, parentheses, parentheses. We have 2x minus 1. And here we have 7x minus 5, 7x minus 5. All right? Okay. Always double check your entry. If you have extra time, it's challenging because 40 questions in 80 minutes, it averagely you only have 2 minutes for each question. But if you have extra time, you should always double check, okay? Very good. Next, question number 23. Using the factoring method, solve for the roots of the quadratic equation. So this is to solve a quadratic equation. Right side is 0, left side is a quadratic trinomial with leading coefficient 1. This quadratic equation is already in the standard form. And we're going to use the shortcut method to solve this equation. We're going to factor the left side. Think about Which two numbers multiply to negative 54 add up to negative 3? Since the two numbers multiply to negative, we're going to have a negative number, a positive number, right? The two integers must have opposite sign. And the negative number has a bigger absolute value. Think about which two numbers. Positive 6, negative 9. Multiply to negative 54. Add up to negative 3, right? And what's the opposites of the two numbers in red? Negative 6 and positive 9. Negative 6, comma. It says use a comma to separate answers. Comma, positive 9. So those two numbers are the two solutions. Very straightforward. Question number 24. A factor. This obviously is a difference of two squares, right? But this question is degree 4. This binomial is degree 4. If degree 4 is good news because 4 is even. Because we're able to write x to the power 4 as the square of x squared. You see what happened here? So the first base 1, is x squared. Base 2 is 4. I mentioned in the class that you must have this step write down base 1, base 2 are square together, right? When you factor a binomial, and the binomial is the difference of two squares. So first base x squared, second base 4. And we're able to factor this difference of two squares as parentheses times parentheses. Base 1 plus base 2, base 1 minus base 2. However, we're not done yet. We're gonna factor x squared minus 4. In this part, this factor x squared minus 4 is not prime. It is factorable. In fact, x squared minus 4 is also a perfect square. Is also a difference of two squares. X squared minus 4 is x squared minus 2 squared. So base 1 is x, base 2 is 2. So we're going to apply the formula one more time to write x squared minus 4 as x plus 2, x minus 2. What happened to x squared plus 4? Not factorable. We mentioned in the class, I have a slide. A table tells you a sum of two squares is a prime, right? Unless there's a GCF can be factored out. But x squared plus 4, there's no GCF. GCF is 1. So this part is prime. The result is going to be a multiplication of three factors. Okay, 3 factors. The first factor, x squared plus 4. X squared plus x squared. Sorry about that. X squared plus 4. So that's x squared plus 4. And it's x plus 2. X minus 2. Yeah, always double check your entry. Next, question number 25. Factoring, right? Okay, this is a trinomial. Obviously, the GCF is not 1. Yeah, I see 8, 48, 72. Yeah, GCF is 8, right? Because 8 goes into 48 6 times, goes into 72 9 times. Also, we have x cubed, x squared, x. So x is common. We have y cubed, y cubed, y cubed. So y cubed is also common. GCF of this trinomial is 8x y cubed. All right. If you do not remember how to write a content in the parentheses, use the technique I taught in the class. From 1 over GCF. From 2 over GCF. From 3 over GCF, right? And double check the simplify the 3 terms in the parentheses. After we simplify the x squared minus 6x plus 9, right? Yeah, ideally, we want to have a quadratic trinomial. It is quadratic trinomial. So is x squared minus 6 6x minus 6x plus 9. Okay. You can use shortcut method, or if you notice, you can see this triangle is a perfect square triangle. That actually is x minus 3 to the power 2. Okay. You can double check x minus 3, x minus 3. 93, 93 multiplied to 9, 93, 93 add up to 96, right? So that's the final answer. It is factorable. The result is 8xy cubed, 8xy cubed times parentheses to the power of 2. The base of the perfect square is x minus 3. Double check your entry. Next, question number 26. Okay, so we have this shape, right? A figure. We want to find the area of the shaded region. Yeah, read the question. Find a polynomial in factored form of the shaded area. Both figures are rectangles with the dimensions as labeled. Okay, so the area of the shaded region is the area of the bigger rectangle minus the area of the smaller rectangle. All right, the bigger rectangle has base 13, height 8. So 13 times 8. And a small rectangle has base x plus 5, height x. So x plus 5 times x. And that's the expression that represents the shaded area. Let's simplify. Simplify and then factor, right? Because the question requires to give the result as a factored form. Let's see what is 13 times 8. 104. Double check. Yeah, 104. 3 times 8 is 24. Okay, 104. And then we can write x in front of x plus 5 if that makes you feel a little bit more convenient. Distribute negative x times x, negative x squared. Negative x times 5, negative 5x. So we have negative x squared minus 5x plus 104. We need to give the result as a factored form, right? Remember, how do we process a trinomial if the leading coefficient is -1? We need to factor -1 out. And inside the parentheses, we have x squared plus 5x minus 104. Shortcut, right? We need to find the two integers multiplied to negative 104. Add up to positive 5. Yeah, so let's see how do we find those two numbers. We can try to factor 104. 1 times 104. The difference of two numbers have to be 5, right? 2 times 52, 3 doesn't work. 4 times 26, 5 doesn't work. 6 doesn't work. 7, no. 8 times 13. There we go. We got it, right? It's actually, so the positive number has big absolute value. Positive 13 and negative 8. Positive 13, negative 8, they multiply to negative 104, add up to 5. And that's the result. That's the result. So we're going to have negative parentheses times parentheses, x minus 8, x plus 13. Yeah, double check the entry. All right, next. Question number 27. Remove the GCF. Yeah, remove actually not a very accurate word here. Factor out the GCF. Check your answer by multiplication. Okay, it's a binomial, very busy. GCF is not 1. GCF is 8. X fifth, X fourth, so X fourth. Pick the one with the lower degree. Y fourth, Y fourth. And then factor out the GCF. Inside the parentheses, we're gonna have x plus 2. All right. If you are not sure, double check by distributive property. 8x fifth, y fourth. 16x fourth, that's fourth, right? And y fourth. Okay, that's the result. X plus 2 inside the parentheses, that is the prime, okay? Yeah, random variable, sorry, not random variable. Variable x plus a constant, that binomial is always prime. So we have 8x to the power 4 times y to the power 4 8x to the power 4th, y to the power 4th, and then times the parentheses, x plus 2. X plus 2. All right. Next, question number 28. Solve the equation, right? Obviously, factoring method works. So x squared plus 8x plus 15, all positive, is going to be not difficult. The two numbers are going to be both positive. 3 and 5, right? 3 and 5 multiplied to 15 add up to 8. And what are the opposites of the two numbers in red? -3, -5. And those are the two solutions. Very straightforward. 93, comma, 95. Make sure that's a comma, not a dot. Okay, very good. Question number 29. This is a lot of words, right? Let's read it. If there are n people, okay, this is an application problem. If there are n people at a party and each person shakes hands with every other person once, the number of handshakes that take place among the n people is half times n squared minus n. So if you have a probability background, you would understand why the number of handshakes is half n squared minus n, right? It's a combination actually. But we don't have to know that. So it's given. Barry is hosting a holiday party and has invited 7 friends. If all his friends attend the party and everyone, including Barry, that's very important information, including Barry, shakes hands with everyone else at the party, how many handshakes will take place? A lot going on, right? Basically, it tells you n equals 7 plus 1, 7 friends, and Barry himself, 7 plus 1 is 8. All we need to do is to plug in n equals 8 to find the value for h. Let's do that. N squared, 8 squared minus 8. 8 squared is 64 minus 8. 64 minus 8, what is that? 56, right? 56. 14 minus 8, 6, okay. And this bit is half, right? Half of 56 is 28. 28. So the number of handshakes, 28. Question number 30. Factor using the difference of two squares formula. Okay, since the problem tells us it is a difference of two squares, we only need all we need to do is to find the two bases, right? The two bases are 1 and 7x. So 1 plus 7x times 1 minus 7x. Double check. Correct. Next. Let's see if I want to continue. I'm gonna see you in the next video. All right. Yeah, we keep 10 questions each video.